Welcome back to Chapter 10 in Math 121. We're going to explore the ideas surrounding geometry and spend some time talking about some key concepts here. In today's section, we're going to be looking at points, lines, planes, and angles. So let's dive in. Or hopefully we'll get to a point where we can understand the relationships between points, lines, planes, and the basis of geometry. We'll look at solving some problems involving angle measures and then solve problems involving angles formed by parallel lines and transversals. All right. What is a point? A point is a representation of a small dot. Key things to note about a point is it has no length, width, or thickness. It is just a representation. So we have a point designated A, and points are often written in geometry with capital letters indicating that it's the point. A line is a segment connecting two or going through 2 points. And it may not necessarily just be a segment. It could extend into infinity in both directions. Two lines are required to make a point, and it's the relationship of the shortest path connecting those two planes on a plane. And a plane is a flat surface. So think of like a sheet of paper, for example, is a sort of a physical relation understanding of a plane, even though a plane doesn't have a thickness. So a plane is a infinitely thin, no thickness relationship, but it also can extend in infinite directions. I was trying to think of an example. So a sheet of paper is an example of a plane, but it doesn't have a sheet of paper has some thickness to it. So, um, but it is flat, and you can have points made in your line in your plane, and you can have points in your plane. Okay, a line may be named by any of the points, two of its points. So, if you have a line like this, and pretend for a second that I've drawn that. So that's a really bad A. B, and let's say it's hard to make points on here. So imagine I have these 4 points on this line. I could name this A, B. I can name it A, C. I can name it B, C. Typically, we refer to any 2 points. You can name the line AD. So any naming is not unique. There's no standard convention to a line segment. Uh, a half line is formed when you have, let's say, it starts at point A and then it goes off in, let's say, that direction. So you may have something that looks like this. So this is where it terminates. Um, and then a ray is very much the same idea, but it's an endpoint there that includes, okay, so it includes the endpoints. And a line segment is just the portion. So let's say this is an example of a line segment. Okay. All right. And moving on. So here are images of that. So again, the half line segment, which is what I was trying to draw here. That was supposed to be an open circle for the half line, which is what you see here. Drawing, and then the ray includes that point. You should note that that for half lines and rays, the starting point goes first, and where it's going to, or where the arrow's kind of pointing at, goes next. Okay. So that is probably the only convention that is pretty standard in geometry outside of that. Okay. Two rays form a line, form that come together to at a common center, or common point, form a vertex, and that vertex forms an angle, and that angle is often measured with or written with this kind of looks like an eyeball, right? Or like if you imagine like an eye there, it kind of looks like an eye. Well, that's a symbol for a uh, an angle, and then the vertex angle. That's what this is saying is measured or it's talking about. So sometimes we refer to. So if I wanted to name this angle 1, I could write this as angle B, where B is the vertex, or I could write that equivalently as equal to. It's a big one, but that would be angle 1. So I'm trying to draw that symbol. And then also, I could also write this as angle. And we usually start on the terminus side and then go but the most important thing is that the vertex angle is always in the middle. So I can call this A, B, C. And so these three measurements or three names are three different ways of referring to the same angle. You can call it CBA, but just recognize that would mean that you're going from here down and this way. Okay, so since we usually read up and left to right, this is going to be A, B, C, this angle. Okay. Measuring angles and using degrees. Angles are measured by the amount of rotation. So from the positive x-axis. So if this is my x-axis here, then as I rotate this direction, okay, this is my ray out. This is the angle I'm measuring, and it's measuring that direction. This is considered a positive. We call it counterclockwise, often written as CCW, so counterclockwise. If you remember an analog clock, you have 12 at the top, and then 1, and then 2, right? That's a 2, and so on and so forth around. Clockwise goes in this direction, so this is clockwise. Counterclockwise is measured going from, again, basically the left, kind of rotating to the left, so to speak. Okay, so that's counterclockwise, and we designate that as the positive measurement of the angle. A measurement of 1 degree is 1/360th of a circle. 360 degrees is what we accumulate. Going all the way around a circle is 360 degrees, which we then call 1 degree. So that ratio. So we divide this up into 360 little divisions, then 1/60th, 360th of that would be a degree signal by this little circle thing. Okay. Measuring angles. So here's a clock. So this is moving clockwise. So we have our center here, and have one ray being one of the arms, the other ray being the hour and the minute clock. And so as this moves clockwise, then the amount of measure through this moving from 12 to 2 is 2/12, or 1/6 of a complete rotation. And it's gone 1/6 of a rotation. And so how much is that? That's 60 degrees. Okay, so 1/60th of 360 degrees is 60 degrees. Measuring angles by their measurement. Okay, so again, that's less than 90 degrees. 90 degrees would be at 3 o'clock or at 9 o'clock. 180 degrees would be at 6 o'clock. Okay, keeping the noon standard here. So anything that's a right angle is considered 90 degrees. Less than 90 degrees, if the angle is less than 90, it's called acute. If it's greater than 90 but less than 180, we call it obtuse. And then we call straight 180 degrees. Okay. And so looking at a protractor, you can find the measure using a protractor. Some special angles, complementary angles is one word, and this comes up quite a bit, especially in dealing with triangles. Complementary angles are angles whose sum is 90 degrees. Okay, so if we look at this angle, we'll call it capital A, and this angle right here, capital B. So then A plus B, that sum is 90 degrees. Okay. They're called complementary if that's true. Supplementary angles are very similar, however, in that situation, let's say you have this, and this is A, and this is B, and then the total measure is 180 degrees. In other words, the measure of a straight line is considered 180 degrees, and that's equal to A plus B. Okay, so these are called supplementary when their sum is 180 degrees. They're complementary if they equal 90 degrees. All right, so here's what that might look like. Find the measure of DBC. So notice B is the vertex angle. So we go DBC. So this is the angle that we're looking for, that's unknown here. We know that they're complementary, so the total of these two angles needs to add up to the right angle here. The right angle is measured by this little box. That's how we indicate this measurement means 90 degrees. So 90 minus this angle being 62 should give us the total here, which is 28 degrees. Or what plus 62 degrees equals 90 is the question we're trying to answer. Okay, so subtracting 62 from both sides gives us then the what that we're looking for, which is the measure of angle DBC. Okay, here's a supplementary example where these two angles must add to 180 degrees. That's what we're saying here. They gave us a relationship that the measure of this angle, ABD, is greater than the measure of 66 degrees greater than the measure of this angle. So whatever this angle is, if we add 66 degrees, that would give us this angle. So that gives us a relationship x plus 66 is 180. Adding the two x's together, we get 2x plus 66 is 180. Subtracting 66 from both sides, we get 2x is equal to 114. And then dividing both sides by 2, we get x is 57 degrees, which means this angle, CBD, is, or DBC, as it's referring to here, is 57 degrees. And then DBC plus the 66 degrees is 123 degrees, and that would be the measure of this angle here. One thing to notice, vertical angles are always congruent, and that should be easy to verify with your fingers. If you cross, you can see that the angle measured between your two index fingers on the top is the same as the one on the bottom. And then if you look, and you can kind of see it as you move your fingers back and forth. And if you look at the sides here, it should be intuitive that the angle that's formed right here is the same as the angle that's formed right here. Okay. And those are called vertical angles. And so we say vertical angles are congruent. So 68 degrees is equal to the angle 1. And then these two are vertical angles, but 68 degrees and 2 are also supplementary angles. And so this is 68 degrees. So 180 minus 68, which is what you see here, equal to 112, is the measure of this angle 2. And knowing that, then we can figure out what angle 3 is. Okay, so you can find a lot of angles out by just knowing a few pieces of information. All right, now we're getting into special line relationships. So parallel lines introduce a lot of useful and powerful information. So parallel lines are lines that never intersect, or we say sometimes that intersect at infinity. The intersecting lines are lines that cross each other. So here, the transversal is the line that crosses both of these parallel lines. Okay, and the intersecting line here is this line and the transversal. So the transversal is the name of the line that crosses both of these places. An intersecting line would just be if it stopped here, for example. Okay. All right, let's dive into all the information. So this is a lot of stuff at once, but just to kind of keep things in conjunction, it's helpful to think of the pictures. Okay, alternate interior. Alternate means like they're flipping and flopping. So angle 8 or 3 here is the same as angle 6. Those are alternate interior, and they say they're congruent, which means they're the same. Likewise, alternate exterior angles are congruent. And then corresponding angles are also congruent. So those three relationships are really important. And honestly, if you just know one, you can kind of get the rest from that using vertical angles and the fact that measure of an angle is 180 degrees of a straight line, I should say. It's 180 degrees. You can kind of get the other ones. So you don't have to necessarily memorize all three, though they come up so often. It's really good to note or to kind of make those second nature. Parallel lines and angle pairs. So alternate interior angles have the same measure, alternate exterior angles have the same measure, and corresponding angles have the same measure. So those are the ones to know. All right, so let's look at how we can use this then to find all these different angles. So if we know that the measure of angle 8 here is 35 degrees, then angle 1 is vertical angles. So those two we get right away. And then we can get angle 6 or angle 7 from the fact that they're supplementary. So if we look at this being supplementary, then angle 7 is 180 minus 35, which is 145 degrees. In this situation, they chose to measure to use the fact that these angles are also supplementary. And so again, 180 minus 35 gives me that angle 6 is 145. And angle 6 and 7 we know are the same because they're vertical angles. Okay. Now, knowing that, we also know that angle 8 and angle 2 are the same because they're alternate interior angles. So angle 2 here and angle 8 are the same. Angle 8 is 35, so angle 2 is 35, which means that angle 5 is 35 because they're vertical angles. And then just like we found how we found angle 6 or angle 7 earlier, knowing that 5 is the same as 2, then we can use the 180 degrees, the fact that these are supplementary angles, or we could recognize that we know what 6 is, and we know what 3 is congruent to 6 because they are the relationship. Let's see, right? I was going to show a picture because it's helpful. So they're corresponding angles, and it kind of looks like this, except for we're looking at 7 and 3 in this image. So these angles are congruent because they're corresponding angles, which is what we're seeing here. So 6 and 3 are corresponding angles. Yeah. Likewise, 5 and angle 5 and 8 are also corresponding angles. So we know angle 5 from. So you can see how you can get all these angles pretty quickly once you know the relationships describing them. Okay. All right. I hope that was helpful, and I'll see you in the next video.